reciprocal trig graphs. Well, first let's graph your basic. Sine we did in our previous section. We know the center line is 0, height of 1, because true sine fluctuates between 1 and -1. We've got 0, 90, 180, 270, 360 degrees. And sine, one complete sine curve is from 0 to 360. Now, let's say if we didn't want sine, we wanted cosecant. Well, the way you graph reciprocal graphs is there's 2, if not 3 steps. The first one is wherever in the original there was a 0, now there's an asymptote. Because if you flip a 0, you get an undefined. So I'm going to use my purple pen. So here's a 0, vertical asymptote. Here's a 0, vertical asymptote. 0, vertical asymptote. If you had vertical asymptotes, now if you flip it, you would have zeros. The second thing is wherever it's increasing, well, when you take its reciprocal, it's going to be decreasing. Because see, like if I had 2, 3, 4, 5, it's increasing. It's getting bigger. But if I flipped them, 1/2, 1/3, 1/4, 1/5, it's getting smaller. So see how from here to this point at 90, you're increasing. Well, the reciprocal means you've got to be decreasing. Decreasing, increasing, approaching those asymptotes, decreasing, increasing, increasing, decreasing. So whenever you need to graph cosecant, you're going to do your asymptotes, swoop, swoop. Now it's going to be the same thing with cosine and secant. Well, first let's do traditional cosine, 0, 90, 180, 270. So remember your normal graph for cosine still fluctuates between 1 and -1, but looks like that. So if you wanted to find secant, first step, remember for reciprocals, wherever you have zeros, now they become vertical asymptotes. And remember, those are going on forever. And then, to make secant, this one, notice how your hump is going this way, so it's going to be going that way. That way. That way. If you look, it kind of looks like a frowny face. If you made a nose, eyes there, the frown. But anyway, that's what secant looks like. Last but not least, tangent to cotangent. Tangent, you know, if you take 90, 180, 270, this gives you one complete curve. Just like if you wanted to go over here to -90 at 0, one complete curve. Well, the same thing is going to happen. Remember on this, with cotangent, zeros become asymptotes. Asymptotes become zeros. And then if tangent is always increasing, that means cotangent is always decreasing. So to make it a little bit prettier for you, so tangent, you know, there's always one complete curve between 90 and 270. And it's always increasing. Cotangent, You've got 0 and 180, 180 and 360. And it is always decreasing. And you can do things to it as needed. Let's say you wanted to do a funky one like we were doing on sine and cosine of, let's say it was 6 plus 4 sine of 5 x minus 200. And let's say instead of sine, we wanted cosecant. Well, first you are going to graph sine. So center line of 6, amplitude or height of 4, so add 4, subtract 4. Sine curve, negative 200, so starts at positive 200. There's 5 curves in 360 degrees. So 5 into 360, 72. So 200 plus 72, 272. And that's it as far as for sine. Now to make it cosecant. Zeros become asymptotes. Flip, flip. Just like let's do a cosine or a secant. Center line negative 3, height of 5, so add 5, subtract 5. Secant, so we know that goes with cosine. What makes that 0? Negative 50. And a 4 into 360 is 90. So if you add 90, you get 40. And now last step, the reciprocal part. Zeros become asymptotes. And there's your frowny face. As normal, if there's anything that you need further, please message me and I'll be glad to answer questions, work more problems. As these, of course, are in degrees, radians are the same, except a little bit messier to deal with, but still the same. Have a great day.